Okay guys, so this lesson is all about taking the integrals of exponential and trig functions. And guess what? If you know your derivatives, you know your integrals, all right? If you do not know your derivatives, I'm going to ask you to go ahead and learn those so that we can also learn our integrals, okay? Check it out. Okay, here's a really good little graphic on all of our trig derivatives. Derivative sine is cosine. Screenshot this if you don't know these. Derivative cosine is negative sine. Derivative tangent is secant squared. Derivative cosecant is negative cosecant cotangent. Derivative of secant is secant tangent. And the derivative cotangent is negative cosecant squared. Now what we're going to do with each of these is integrate them, and they just go backwards. Okay, so let me show you the backwards ones. All right, cool. This is a good one because this actually shows me the derivatives and the integrals on the same little figure here. And you can see, like, if the derivative of sine is cosine, the integral of cosine is sine. If the derivative of cosine is negative sine, the integral of sine, that negative can just move over and be negative cosine. So really the positives and negatives are the hardest things to remember. Now, when we were memorizing trig derivatives, we said anything that starts with a c has a negative derivative. Well, that means anything that equals a c over here will have the negative integral. Okay? All right, so we're also going to talk about e's and ln's. And if you guys remember, the derivative of e to the x was e to the x. So the integral of e to the x is e to the x. Easy stuff, right? The derivative of a to the x. Let's see if you remember this. So when we did derivatives, e to the x was e to the x. Do you guys remember a to the x was a to the x times ln a? That was the derivative. Okay? Now look, the integral is a to the x divided by ln a because I'm taking an integral, so I'm going backwards. And then all my trig derivatives are just memorized backwards, okay? They have this little chart here. I don't know if that helps you to remember like derivatives and integrals, but anyway, you just kind of have to know them. Okay, so let's look at a few examples. When I see a -3 in here, I can just bring that out in front. And then my integral of sine is negative cosine. Okay, and so -3 negative cosine just gives me 3 cosine of x plus c. Don't forget, we're still doing our plus c's on everything. All right. Okay, find the integral here. Well, the integral of e to the x is e to the x. The integral of 2 to the x is 2 to the x, but I have to divide that one by ln of 2 and then put a plus c. All right. Okay, let's check out this. We've got... Well, first, this t squared cube root, I'm going to switch that to t to the 2/3. I think I'm ready to go now. So it's 5. If I add 1 to that, I'm going to get t to the 5/3 over 5/3. We talked about that in class, okay? But remember, t to the 5/3 over 5/3 is the same as saying t to the 5/3 times 3/5. All right? And I'll reduce that in just a second. Okay, the integral of cosine is positive sine, and the integral of 1 is t plus a constant. So I can simplify those, right? So it's 3t to the 5/3 plus 3 sine t minus t plus a constant. All right? Okay, where you guys see this 4 right here, we actually can also bring that out in front. The only thing is when I bring it out, because the 4 is on the bottom, it's going to be a 1/4. Okay? I'm just moving that out. And then if I say, what's the integral of secant tangent? That's one of the ones we memorize. We know the derivative of secant is secant tangent. So the integral of secant tangent is secant. Okay? So we're just going backwards on all these things. All right? Okay, here we go. If the derivative is cosecant squared, and f of 5 pi over 4 equals 3, find f of x. I'm going to go backwards one step here, guys. Now, cosecant squared, if you remember, up here, look, they write it a little bit differently, but you guys see that? Negative, the cosecant squared is just in there, and the integral of cosecant squared is negative cotangent. Because the derivative of, come down here. There we go, because the derivative of cotangent was negative cosecant squared. Okay, so the integral will be negative cotangent plus c. And then, do you guys remember that this is how we are allowed to find c? And what it says is if x is 5 pi over 4, it should equal 3. F of x should equal 3, okay? So negative cotan 5 pi over 4 equals 3. Let's see, we have to figure out what the cotangent of 5 pi over 4 is. In order to get that, what I need is the tangent of pi over 4. And I know that the tangent of pi over 4 is 1. Now, 5 pi over 4 will go into the third quadrant, okay, because it's a little bit past 5. So that's 5 pi over 4, and it goes ASTC. So tangent of 5 pi over 4 is positive 1, which means cotangent of 5 pi over 4 is also positive 1. Okay, so when I come back over to here, it's negative of a positive 1. So when I solve for C, C is 4, and I can write my final equation as f of x equals negative cotangent of x plus 4. Okay? And that's it. Doesn't get to anything really crazy until 6.3, so hopefully, I was really short. You guys better watch that lesson by tomorrow, 6 minutes. Let's go.